Right, to find equations of plane, we need the normal of plane, and then one of these points will do to form the equation of plane. So what we do is get two vectors, A, B, and AC, from using these 3 points already, and then we find normal. The fastest way, of course, is to find a cross product of A, B, and AC. Now you perform the calculation properly, you get 4 to negative 4. But we don't really need such large numbers. We can just find something like this. We factor the common factor. So yeah, it's 2, 1, and negative 2. So we just end up using this 2, 1, negative 2 vector, which is also normal to the plane. Next, we can assume that the P, X, Y, Z and is on P, a plane P. Let's call it P1 perhaps. So we know that A, P1, we can take one of any points, but we choose A, we can use B or C. Dot N would be 0. So in other words, we're trying to calculate this. X minus 2, Y minus 2, and then Z minus 1. And it's dot of 2, 1, negative 2 equals to 0. If we just perform the dot product and simplify, it should end up getting 2x and y minus 2z equals to 4. Now x for part B, let's go right here. For part B, we just the equation of the line which is perpendicular to the plane. Well, we can think of this way. There's a plane P, and there's a line that is perpendicular to the plane, like this. So in other words, you can see that the line is also parallel to the normal of P, and in that way we can say that we can just let the direction vector of the line be a normal. We can use the normal, which is this one, the normal. That would be 2, 1, negative 2, and just use the point that we talked about. This is the point B. So that means we know that the x will be by parametric form. Any form will be okay. We just use parametric form. Will be x1 plus u1t. In other words, x equals to 6 plus 2t. And of course, the 6 is the x1, and the u1 is the x component of direction vector, and you can complete this. Y be equivalent to negative 2 plus t, and then z is 3 minus 2t, where t is a parameter. Then finally, to respond to part C, we want to talk about the shortest distance between the plane and the point, and the formula to calculate that will be this one, A of x plus by cz. Now this will be minus d over the square root of a squared plus b squared plus c squared. This is, of course, we're talking about for the equation of a plane in the form of a x plus by plus cz equals to d. Well, perhaps to avoid confusion, I should put x1, y1, and z1 for the coordinates of the point we're going to calculate for. Now, so in this case, the shortest distance is therefore, the plane is this one. So we're going to use 2, 1, and negative 2, and the point is this 2, 6, and negative 3. So we are looking at 2 times. Okay, talking about this here, 2, 6, and negative 3 will be the coordinates of point D, and divided by here, 2 squared plus 1 squared and negative 2 squared, the coefficients of the plane, and finally you get 12 over 3, and that's 4 units that's required.